Part 3, Composition of Functions. Suppose f and g are two functions. The composite of g with f, denoted g of f, which looks like a little open circle in the middle of g and f, is defined by the formula g of f of x equals g of f of x, provided x is in the domain of f and f of x is in the domain of g. So what does this mean to have g of f of x? If we first start with x, and we would evaluate the inside function first. So we would find f of x, and then whatever we get for f of x, we would find g of that number, and we end up with g of f of x. So the inside function gets evaluated first. So for f of x equals 2x minus 3, and g of x equals x squared minus 2x plus 5, find g of f of x. So we'll find g of f of x, which is g of 2x minus 3, which equals 2x minus 3 squared minus 2 times 2x minus 3 plus 5. So we substituted into g, all the x's in g, we substituted 2x minus 3. For f of x equals 1 over x plus 1 and g of x equals 3 over x, find f of g of x. So we want to find f of g of x, which is f of 3 over x. So we will substitute 3 over x in for all the x's in f of x. So we have 1 over 3 over x plus 1. Now, it's probably not a good idea to leave a fraction inside a fraction. So I'm going to multiply my numerator and denominator of the big fraction, the whole fraction, by the common denominator of any fraction inside, which is x. So I'll multiply by x over x, and I get x divided by 3x over x plus 1 times x, or x divided by 3 plus x. For f of x equals x squared minus 2, and g of x equals the cube root of x plus 6, find f of 1. So what does that mean? f of 1 means we're going to find f of 1. First of all, that's our inside function, f of 1. So f of 1 is 1 squared minus 2, or negative 1. So now I'm going to substitute that back into f. So f of negative 1 is negative 1 squared minus 2, or 1 minus 2, which is negative 1. Now let's find the domain of composite functions. Find the domain of g of f of x, where f of x equals x plus 1, and g of x is the square root of x. So g of f of x, first we look at the domain of the inside function, or f of x. So the domain of f of x is all real numbers. And then we look at the domain of the outside function. So the square root of g of x is the square root of x. So we want the square root of f of x. The domain of that is where what's inside the square root greater than or equal to 0. So we need f of x greater than or equal to 0, or x plus 1 greater than or equal to 0. So x is greater than or equal to negative 1. So our domain of g and f, g of f, would be negative 1 to infinity. Find the domain of f of g of x, where f of x equals 2x plus 5, and g of x equals 2 divided by x plus 3. So f of g of x, or f of g of x, the domain of the inside function, x cannot be negative 3. We see that that would make our denominator equal to 0, and we can't divide by 0. So our domain is everything, all real numbers except for negative 3. The domain of the outside function, so f of g of x, so 2 times g of x plus 5, and this is not going to give us any additional restrictions because 2 times g of x plus 5, our domain is still just x cannot be negative 3. So our domain of f of g would be negative infinity to negative 3, union negative 3 to infinity. An online clothing retailer offers 10% discounts on ski jackets. Additionally, the retailer offers a $50 rebate on the purchase of a ski jacket. Let x represent the listed price of the ski jacket. Part A, find a function f that models the purchase price of a ski jacket if only the 10% discount applies. So our f of x, if they have a 10% discount, that means we're going to pay 90%. So our function would be f of x equals 0.90x. Part B, find a function g that models the purchase price of a ski jacket if only the $50 rebate applies. So our function here, we pay the full price and then get $50 rebate back. So g of x would be x minus 50. So now let's find f of g and g of f and talk about what they represent. So first of all, f of g of x would be f of x minus 50, which is 0.9 times x minus 50. So in this case, if we look at our order of operations, x minus 50, so that happens first, the $50 rebate first, and then 10% off what was left. But if I find g of f of x, so that is g of 0.9x, then we have 0.9x minus 50 without parentheses. So this time, with g of f of x, the 10% discount happened first, and then the $50 rebate on what was left.